Okay, hello everyone. I'm hoping people on Zoom can hear us. If someone can, yes, okay, perfect. Okay, welcome to the second session of the AI and ML in Medicine course. We're excited to see all of your faces in person here, and also a lot of people on Zoom. We're getting close to 100 right now, so let's see if we can break that record. Okay. And so today we're gonna have a bit of a lecture / workshop. We're gonna do a bit of a introduction to programming in Python. Afia is gonna tell us about that. She's a grad student in the comp sci department. And before we get that started, I'm gonna just quickly show this. So make sure you've received an invite to our Slack. Because that's what we're going to be using for the course material from now on. I'm going to try not to clutter people's inboxes as much as I can. So if you're on the Slack, then we don't have to use the traditional email method. And then the recordings and slides are going to be posted there as well. With that being said, I will pass this on to Afia.
Hi, everyone. I'm Afia, grad student at computing science. I am at the second year of my master's. So in this workshop, we are going to learn about the basics of one particular programming language, which is Python. So let's start. This one is for attendance. I guess you know what is this for. And we will show up this again at the end. So I'm just skipping right now. So we will start with the definition of programming, what is programming, and some basic definitions that we are going to use later. And then we will look at some of the basic things that we need to program in Python, because in the next lecture, we will learn how we can implement machine learning algorithms using Python. So this is the basic outline. Let's start with the basic definition. So what is programming? Programming, you can translate is as talking to computer. When two people talk, what do we use? We use natural language. But when I want to talk to a computer, I just can't say, do something for me, print something for me, show me a video. I have to use some language that the computer understands. And that's programming language. So how many natural languages do we have? We have a lots of natural language, for example, English, French, Spanish, and some other languages. So just like these, we have a number of programming languages, for example, C or C++, Java, Python, and some lower level languages there are also. So different languages have different syntax, different grammars, just like natural languages. And in this course, we are learning Python. It's one of the most popular programming languages, and its popularity has increased after the introduction of machine learning and artificial intelligence. Python's library is one of the most used library in this area. So yeah, this is the basic of programming. I can share a little fun fact with you. When I started my undergrad, I didn't have any idea about programming and computers. And I chose computing science because I thought it would be the easiest subject, because they will teach us how to operate a computer. That's not true. They actually taught us programming languages and how to make softwares, how to write programs. That's a whole new different thing. So yeah, that was like a shock for me. And so when we talk about programming, we are not using a software. You can think we are kind of trying to make a software so that people can use that. For all the programming languages, there are some very common basic things. For example, we have alphabets in all the languages. So we will start with the basic definitions that are common in all the programming languages. Then we will switch for the special things that are only for Python. So the first one is variable. What is a variable? We have RAM, random access memory, in all our computers. We know RAM. So variable is, we can consider it's a location in our RAM where we can store some value. For example, say this is my RAM 8x8 memory boxes. So if I write this line, x equal to 10 in a Python editor, what will it do? It will take some location from this memory, from my RAM, and it will name this as x, and it will put the value 10 inside this. For let's look at another example. I can write this in a Python editor. It will again take a block from the available memory. It will name the block as whatever I said here. So it's customer name. And it will place the value, whatever I wrote here, John Doe, inside that memory. So whenever I say read, what is my customer name? It will tell me your customer name is John Doe. So this is what variable is. This is like the most basic thing in all the programming languages. Now, then we have operators. We have our variables. For example, we have a lot of memory locations with a lot of values. We somehow need to do some kind of operation so that it works. And the operators are very similar to the operators in mathematics. So we have 3 types of operators in the programming languages. We know all about arithmetic operators, addition, subtraction, and these things. Then we know these also, relational operators, less than, greater than, and these things. And this is kind of new because these are not mathematical operators. We have never used them in our exams. These are for programming languages. So I'll start with this. Whenever I write x equal to 10, what does that mean? Take a location from your memory, name it as x, and put the value 10 inside this. So this is called the assignment operation. We are assigning a value to a memory. So this is basic assignment. We can also do an addition assignment, that's plus equal. What is this? If I write this, x plus equal 5, this is similar to this line. Now, this doesn't make any sense. X is equal to x plus 5. If we think mathematically, this is totally wrong. But in programming, this is right. It means add 5 to x and store the whole thing inside x. So what will it do? Now my x has the value 10. I will add 5. It will be 15. And the whole value 15 will be stored inside x. So now my x will be 15. Subtraction assignment is similar. We subtract and then we assign. Multiplication assignment, we multiply, then we assign. Division assignment, we divide, then we assign. And let's look at the last example. If we write this, that means divide x by 5, take the remainder, and now place it inside your x. So 15, x is now 15, 15 by 5, 5 into 3, 15. My remainder is 0. So now x will be 0. Yeah, so these are the assignment operators. Now we know all these basic operators, addition, subtraction, and this. We also know modulo, we have just seen. And we have 2 more arithmetic operators, integer division and power or exponential. What is integer division? We don't take the floating point. Anything after the decimal point, we don't take that. We only take the integer part. So if I do 15//2, that means it should be 7.5, but x will only store 7 because this is an integer division. And then power or exponential, 2 to the power 3 is 8. So now x will be 8. And we have relational operators. We will learn about these with some examples where we use conditional statements. We will see the examples in our demo portion. And programming language, when I call something a language, it must have some grammatical definitions. So just like natural languages, programming languages have syntax and semantics. What do we mean by syntax? That means it should be grammatically correct. There shouldn't be any kind of spelling mistake or maybe grammatical errors. So this is same in programming language too. For example, if I write this, that means assign the value -9 inside your variable z, which is logical. Equal is an assignment operator, and we can use this. So this is valid. This is also valid. This is also valid. Is this valid? This is not any operator in Python or any other language. // doesn't mean anything. So if I write this and run the Python code, this is my output. It will say there is a syntax error in your code. So syntax error are actually easy to find. Your compiler or your editor will say you have a syntax error in that line. You just look at your code, you will find you have done something wrong. But there's one more thing, that's semantics. And we know what semantics mean if a statement has some valid meaning. For example, I write z is equal to 0. That's a valid syntax. I write y is equal to 500 by z. That's also a valid syntax. I can divide anything by anything. But would it work? No, I cannot divide anything by 0. That's mathematically wrong. So if I run this code, it will say we have a division by 0 error. There's no syntax problem, but it's nothing meaningful. So while writing a code, we have to be careful about these two things, that both my syntax and my semantics should be correct. I guess we are done with the very basic things that are common to all the programming languages. Now let's move to the Python specialization thing. So let's say I want to write some Python code. What should I write? Should I use pen and paper? Or should I use Notepad or maybe Microsoft Word document? How do I run that code? So to write Python code, I can use two different kinds of things, code editors or IDE. Code editors are simple text editors, for example, Notepad++. They will give you the option to write and edit your code. But to run that code, you need some other softwares. That's like too much and it's too basic. But IDE, that's a whole integrated development environment where you have everything. You can write a code, you can edit that, you can, if you have any bug in your code, you can debug that. You can do the version controlling thing. It's like, for example, we have in the softwares, we have so many versions, 0, 0.9, 0.2. So you can control the versions easily. And there are some other options. So we will do the demo using one IDE. There are a lot of IDEs. For example, here is a list of popular Python IDEs. I haven't used all of them. For this course, we will use Google Colab and why. For example, say I want to use VS Code. Usually I use VS Code. For that, we have to install VS Code in all of our machine. It will take 2 classes. But if we want to use Google Colab, that's really easy. We just have to go to the website and we can start writing the code. So Google made this platform for the beginners to start very easily. We don't need to install anything. We just need to go to their website and we just need to type our code and we just press the run button. It will run. It will run on their cloud server. I don't need to install anything on my machine. So that's why we are going to use Google Colab. And I guess from here, we are going to start our demo portion. And I would request you to go to your Google Drive, create a new folder, whatever name you want. And inside the folder, we will create a new Google Colab file where we can write and run our Python codes. For example, this is my Google Drive. So I'm going to create a new folder. Then I go inside this folder. There's nothing in this folder. I have to do this. So press new, then more, and then you will see the option Google Collaboratory. So it will take a new file. It will open a new tab in your browser, and we will see the Google Colab file here. You can name your file, like rename your file here. So let's say you can write whatever name you want, that's your file. And I can write my Python code here and I can press this button to run my code. So I guess we all have done this. Okay. Hi, Shirin, you said please show again. Okay. So you have to go to your Google Drive, create a new folder, go inside that folder, and then new, more, and then Google Collaboratory. So we will, today we will see these 5 things: how to take an input in Python, how to print something, then some basic data types, control structures, function, and finally, introduction to Python libraries. So let's start with simple input and output. If we want to take input from my keyboard using a Python program, I need to write this: input, then something. Input is a predefined Python function that takes input from my keyboard. I don't need to do anything to communicate with my keyboard. It will do everything on my behalf. If I want to print something to my screen, I just need to write print, whatever I need to print. Python will take care of this. The print function will do that work for me. So let's look at. So I guess we all have the, okay. I guess we all have this collaboratory thing. So let's take an input and print the exact same input. So I can do this. And if I run this code, it will tell me to enter something. Whatever I enter here, it will print that again. So one of the very beautiful features of Google Colab is that I can write code in different cells. So for example, I'm done with this cell. I don't want to write anything more here. So I can just press here at code. It will give me a whole new cell to write a new portion of the code. Now let's say, so we are going to take 2 numbers, add them, and then print the result. How can we do this? We need to take 2 inputs from the user. Then we need to add the numbers and we need to print the result. So my first number can be number 1. And I can write input. I have to take another number as my input. So num2 is equal to I need to add these two numbers and store it somewhere else. So I can write this. And finally, I need to print the result. Where is my result? My result is inside the variable num3. So I have to print num3. If I run this code, say first I give the input 3, then my input is 4. My answer should be what, 7? Why is my answer showing 34? Is there anything wrong? There's nothing wrong in this code. Everything is fine. Yeah. Yes. So that's the thing. There's no syntax error. There's kind of a semantic error, because when we take input in Python, it considers the input as string. And when we add two strings, they are just merged together side by side. So 3 and 4, it's printing 3, 4. They're not adding as integer numbers. So what is integer? What is strings? Let's look at those things first, then we'll come back to this again. So in Python, we have different data types. For example, for numbers, we have integer, floats, and also complex, that's complex number. So integers are all real numbers that doesn't have any fraction, 1, 2, 3, 4, 5, and negative numbers. Float are fractional numbers. And for text data, we have the data type string. For example, these things. And there's another data type Boolean that's either true or false. And finally, we have sequence type, list, tuple, dictionaries, and these things. We will look at these in the later portion of this class. So Python has different data types. And when I take an input from my keyboard, the input is always string. When I add to string, they are just merged together. They are not actually being added. So how can I solve this problem? This was my code. The code is, it seems like everything's fine, but it's not working. So whatever I take as my input, I need to convert it to a number. I can do this by doing this. Whatever you have taken as your input, convert it as an integer. I have to do the same for the second number. Now let's see if this works. Now this is working. I still have one more problem. Can anybody tell me? Can I add two floating point numbers like 2.3 and 1.2? Can I do this in this code, using this code? No, because it's always converting to integer. Integers are, they don't work with floating numbers. Let's say I am using 3.2. There will be an error, because I cannot convert 3.2 to integer. How can I solve this? Instead of int, I should have used float. Float is another data type that's for fractional numbers. Now it should work. If anyone has any question, you can ask. Otherwise, it will take a lot of time if we start typing all the codes and then see what happens if we do something wrong and do all the things. It will take like 3 or 4 classes. So I have prepared a whole Google Colab file so that I can quickly show all the code cells and show what happens. And just kindly follow this link. You will find a prepared Google Colab file. We will use that file for the next demo. No need to assign data type to num3. Hi, Karthik. The thing is, if we were working with C or C++, we had to do this. We had to assign every variables a different data type. But in Python, we don't need to do this. Whenever we add two variables, the result is the same type as the operands. Can you post the link? Yes, I guess I can. Hi, if you go to the link, I have sent the link to the Zoom chat thing, and also this will take you to the link. If you open the link, there will be a Google Colab file, and if you go to that file, let me check. So this is the link. Just press open in Colab. It will open the file in Google Colab. So we are done with the first few cells. We have already seen what happens here. Now, our next thing would be the next data structures in Python, that's list and tuple. We have kind of seen integers, floats, and strings, how we can deal with those. And what are lists and tuples? So when we define an integer, what happens? We can store only one value inside a variable. For example, say, I say x is equal to 5. What if I want to store multiple values inside a variable? Can I write this 5, 6, 7, 8? I can write this. One variable can have only one value. But I can, for example, I want to store all the student IDs. I need a very large variable. How can I do this? So list is one of the ways that can help me doing this. I can store multiple values inside a list. So what I need to do is I define some variable, say L, and whatever values I want to put inside L, I just write them inside the third bracket. For example, here L is a list. This is how we define a list. We use the third brackets. Now let's print L. So it will print whatever inside my L. My list has 4 elements. What if I want to insert something in this list? What can I do? Now that's the thing. We have some pre-specified functions that we need to call. How to, like as a beginner, how do I know what's the name of the function? So you just go to Google, you do Python list documentation. You will find something here. And they have all the list, like they have a list of the functions that we can use. So if I write list.append something, that means whatever list I have, something will be appended right at the end of my list. So let's try this one. I can write list.append, say 1099. Now, if I print my list again, my new list has a new value. What if I want to remove something? Again, I need to look at the documentation. I need to find whatever function they have for removing something. It's called list.remove. It will remove the first item. So whatever I need to do, I just need to check in the documentation and it will have all the functions for me. Similar to lists, we have tuples. That's another data structure. So tuples are defined by first bracket. For example, this line, it creates a new tuple which have 7, 8, 9. And this line, it converts my list to a tuple. Now, the very first question that I thought, why do I need two different things for same purpose? List and tuple are kind of same. They are storing multiple values together side by side. Why do I need two things? So the idea is you cannot change the elements inside a tuple. Once it's defined, it's done and it's final. So tuples are immutable. Say I write t2.append 99. This thing won't work. Let's see what happens. This is an error because you cannot append anything in a tuple. You cannot remove anything from a tuple. Whenever a tuple is defined, it's defined forever. You cannot change anything. And that's how it gives you some kind of control. For example, I don't want my user to change my password or maybe something. So I have to use a tuple. But if I use a list, anyone can access that. So these are the basic data structures in Python. Like very basic data structures. We have some other, for example, dictionary, but those are advanced. So in the demo, we have seen list and tuple. Certain dictionaries are a bit advanced. We can see them later. And I have talked about list, and they are the very common method that functions that we use. For example, list.append, list.insert, remove. There are some other functions. We can find them from the list documentation. And similarly, for tuple, these are the very basic operations. We can concatenate two tuples, like merge them. We can check if something is inside a tuple. We can delete a whole tuple. We cannot delete a particular element from a tuple, but we can delete a whole tuple from a memory. That's something we can do. And the next thing we are going to look at is control structures. What is a control structure? Again, let's look at our code. For example, look at this code. Whenever I write lines after lines in a Python editor, what does it do? It executes the first line. So it defines this list. Then it goes to the very next line, it prints that list. Then it goes to the next line, it appends something. So my control is totally sequential. Each lines are executed one after another. What if I don't want that? After this first line, I want to jump right to my fifth line. I want to execute this. Then I want to jump back to my second line. So I want to mess up the default structure of how my Python editor will execute my code. I need to jump here and there in my code. That means I want to mess up with the whole control mechanism. And that's why they are called control structures. I can use two things, either conditional statements or loops, to change how my editor will execute my commands. Let's see one example and it will be clear. Let's go to cell number 6 in the basic Python Colab file. Say our task is we take two numbers as input and we always print the larger one. How can we do this? We know how to take two numbers. We take an input, we convert, we typecast it to a float number. So we do the same thing twice. Okay. So now what is my idea? I will always print the larger number. So how can I do this? First thing, how as a human I will do this. If I have two numbers, I will look at those. If this one is larger, print this, else print this. So my idea is if n1 is larger, print n1, else print n2. This is the very basic idea. I have just written this in English, and that's why it's showing me a lot of syntax errors. Now I have to convert this to Python syntax. If n1 is larger, how can I convert this? It means if n1 is greater than n2, then I should print n1. I need to use a bracket with this print method. Else, I just need to print n2. Again, I need to use a bracket. So this should work. So it will always print a larger number. What will happen if both of my numbers are equal? Can anybody guess? In this code, if both of my numbers are equal, what will happen? What will do to my what will my Python script do? I have never considered this case. I'm a very bad programmer, and I have never considered what will happen if my user gives two inputs were exactly similar. It will check if n1 is larger, otherwise it will come here. So let's see what will happen. Can anybody tell me what will happen?
Say the larger number is 4.
4, why? Because of the if or because of the else?
Because of else.
Yeah. That's right. So I haven't manually checked the condition, but I was lucky this time, it got caught. But usually this doesn't happen. You will always get caught at the boundary cases. But if you want to be like very precise and clear, this should be the actual code. If something is greater than something, you have to print a larger number is that. Otherwise, you should print the numbers are equal. There's nothing larger, nothing smaller. Else, you can just print the larger number is the other one. So why do we call this a control structure? So this line is executed as the very first line. Python start reading from the beginning. This is a comment, this is a comment. It takes an input. It takes another input. Then Python doesn't know what line should be executed. If this is true, this line should be executed. Else, if this is true, this line should be executed. So now I am controlling which line will be executed depending on some condition. That's why we are saying we are messing up with the default control structure. We can do this using conditionals, or we can do this using loops. What are loops? Say I have to do some task again and again for 100 times. What do? I write the code for 100 times? That's not a feasible solution. I write the basic block, I push it inside a loop, and the loop starts doing the code again and again for me. Say, I want to take a number and I want to print the number for 5 consecutive times. Because I'm a math person, I want to see my numbers for 5 times. How can I do this? Again, I take a number as my input. And for 5 times, print your number. What have I done? So this is my goal. For 5 times, I need to print my number. I cannot write for 5 times. This is not Python syntax. I have to change something here. How can I do this? Python syntax is that for I in range. This. So I is some variable. I can write anything here. I can write j, I can write something. I can write loop counter. Whatever name here, but for should be for, because that's why this is colored. So for something in range 0 to 5, that means the value of my loop counter will be 0 and it will print n. Then the value will increase to 1, it will again print n. So if I write this code, n will be printed for 5 consecutive times. So whatever inside my loop, if I write another blocks here, everything will be done for 5 times. So this will look like this. So whatever inside my for loop, it will be repeated. And there's another example. I guess I need to skip all these because I have to like go really fast. So you can try these examples. All the solutions are here. The idea was take a number, print all the odd numbers that are less than or equal to the number. So say I say 7, you have to print 1, 3, and 5. So I take a number, and I should start from 1 to that number. If that number is odd, how can I know if a number is odd? If I divide it by 2, the remainder is 1. Then I should print the number. I guess. Check. So we have seen an example of if-else. We have seen examples of loops. Python has 2 different notations for loops. One is for that we have seen, another one is while. We can also use a while loop. For me, I never use while loops because why should I? But in some cases, they're actually useful, especially when I don't know how many times it's gonna like do the repetition. I can like write while true, do this, and inside I can write some condition to break the whole loop. So there are 2 important keywords: to continue a loop or to break a loop. So let's just see those. For example, in cell number 11, say I have a list of people's names, and my goal is whenever I find a name that starts with A, I should print the name and I should stop searching for other names. So I can use a for loop to search in my list. Does this start with A? No. Go to the next one. Does it start with A? Yes. So print this one and go no further. So I have to tell my loop, you have to break now. So whenever I print something, I need to write break. It will break my loop. Otherwise, my loop will continue till the end, and it will also print this name, but I just want one name. So I can also break my loop anytime. I guess these are like different examples of how can we use a loop. So I'm not gonna explain those again. Now let's look at function. What is a function? When I write print, it prints something. Is it a magic? Who implemented this print thing? The people who wrote the Python language, they have libraries, they have methods, built-in functions, and print is one of the built-in Python functions that we can call to print something. We can also write our own functions. For example, when we do a very large project, there are thousands of lines of codes. It's not practical to write sequential codes. Nobody will understand that. So what we do, we write a block of code, we pack it inside a function, we place it somewhere. So we write like tens or hundreds of functions. We call the functions to do our task. And this is how we write a function in Python. Def means define. I have to use def def to make Python understand that I'm writing a function. Then I can write anything here. This is my function name. I can name whatever I want. And these are the parameters. What are the inputs to my function? So I'm defining a function which will do some addition. It will take 2 inputs, n1 and n2. It will add these 2 numbers and it will return the answer. Now this is an error because I have to change it. So from the main portion of my code, I have to call that function using this exact name. Otherwise, it would be a syntax error. I have to pass how many parameters? 2 parameters. So I'm passing 7 and 2. So this function will execute it. This will be the first line to be executed by Python. Because when I define a function, it's not executed. It means I have defined something, but I haven't called it to be executed. So this will be my first line to be executed. It will call this function with 7 and 2. Then my control will go in this line. It will add 7 and 2 and store it inside sum. It will return sum. Return to whom? To that line who called it. This line called the function. So sum will be here and sum will be placed inside S. If I print S, my S would be 9. So this is how we define functions. And our kind of last example is we are going to write a function to sort a list. Like this is the most complex problem that we are going to solve today. And first, let's look at the idea, how we are going to do this. Say we have a list, this thing, and I want to sort the list from lowest to highest. This thing is not sorted. How can I do this? There are some very common sorting algorithms, and bubble sort is one of them. That's a very popular algorithm. They have the algorithm written in Google. I can just look at that and I can do my code using the exact same procedure. So the basic idea is, if, for example, as a human, what should I do? I would search the whole list. I'll find the lowest number, that's -9. I will place it at the beginning. I will again search. I will do it again. I can do this, or I can do bubble sort. What is bubble sort? The idea is, think you have a bubble. And the bubble can only take 2 values that are consecutive. So I will start from the beginning of the list, and my bubble will look at 0 and -9. My bubble doesn't care about all other elements. It only cares about these 2, if they are sorted or not. Are they sorted? No. So I will sort these 2. I will swap the values. So in this iteration, I will swap the value. It will be -9 and 0. This bubble is done. I will move my bubble to the next slot. So now I have my bubble here. It will compare these 2 values. Are they sorted? 0, then 10. Yes. So I will do nothing. I'll just move my bubble to the new window. Now my bubble is here, 10 and 2. Are they sorted? No. So I have to swap. So I am swapping 2 and 10. Now I have to move my bubble again. 10 and 5. Are they sorted? No. So I have to sort this again. What have I done? My list is not sorted yet, but I have done something. I have made sure whatever happens in my list, this last element is the actual element who should be at this position. So in this first pass, I have made sure that my last element is in right position. I don't care about these things. In my first pass, only this is sorted. So I have to do this again and again, multiple times. In the next pass, this value will be sorted. This box will be sorted. In the next pass, this box will have the right value. In the next pass, this box will have the right value. In the final pass, this box will have the right value. So I am doing 2 repetitive things. I am moving my bubbles. And once my bubble is at the end, I am repeating the whole process from the beginning again. So I need 2 for loops. So this is really like, when we look at this code directly, this is really confusing. So let's try to describe what we are trying to do here first. Say I am trying to write a bubble sort function. So I have to define my function, that's bubble sort. It will take a list, say L, and its goal is that it will sort a list L. How do I sort this? I need 2 for loops. I'm not thinking about the second one right now. It will mess my thinking process. Let's think about my bubble. I have a bubble. I have to move it around my whole list. So for I in range, what is len L? This is the length of my list. From the beginning, I have to go to the end. So from 0, I have to go to the end point of my list. I need a bubble. What was my bubble? If you look at this thing, my bubble only considers 2 consecutive values, value number 0 and value number 1. In the next loop, value number 1 and value number 2. That means compare list I and list I plus 1. So I need to compare the ith element with the next element. If they are not sorted, I have to swap them. Otherwise, I don't have to do anything. I just move my bubble. So I just go back to my for loop. It will do the moving part. How can I do this? How can I compare? If now here comes the funny thing. How do I swap these variables? I am taking these things. Say I need to, this is my variable Li, this is my variable Li plus 1. I need to swap the values. How can I do this? Should I put this one here? Can I do this? If I say whatever value you have in this variable, take it and place it here. This value will be erased. These things will be all messed up. How can I swap this thing here and this thing here? We need another container. We need a third container. We replay we open it up and we put the whole thing in the third container. Now this is empty. We pour it here. Now this is filled with sanitizer, and we take the water. We pour it here. This is filled with water. So to swap, swapping is a very funny thing in programming. To swap two variables, we need a third temporary variable. So I need a third variable. I need to store my water inside that third variable. Say this is temp. Whatever in my Li, I am storing it in my temp. Now my Li is empty. So I can take Li plus 1, I can put it in Li. My temp has the original value. So this is the algorithm for swapping. Temp. Yes, I guess it should work. So if the bubble is not sorted, I need to swap. If this is sorted, I don't need to do anything. So I just do this again and again. Let's see what happens if I do this. So my function will sort the list and it will return the list. I'm not done yet. I need two loops. I have just written one. And I can say my order list equal. Let's see what happens. I need to do this outside of the function definition. Can anybody tell me what happens here? Why I am getting an error? Okay, the thing is, I started at the beginning and yes. Yeah. If we read the error, we will list index out of range. Why? I went to the very last portion of my list. So for example, my bubble is here, it will work fine. Then finally my bubble moves here, it will also work fine. What I did, I went one extra step. I pushed my bubble over my list's boundary. My bubble went here. And it tries to compare -2 with something next. There's nothing next. So I have to do this till length L minus 1. Because I am comparing Li with Li plus 1. When I'm at the end, there's nothing in my Li plus 1. So it should be an error. This should work now. Yes. And in my first pass, as I said, I have the right value at my last place. all the other values may or may not be sorted. And this time I guess I was lucky. It got sorted. So I have just written one for loop. I have to do this for multiple pass. Okay. So I have what should be the value in my last block? It should be 9 because 9 is highest here. I have 9 here, but the rest of the thing is not sorted yet. So for this, I need to do this whole thing multiple times. So I need another for loop. What happens here? So this is my pass number 1. I have to do this again and again for all of the elements. And now I guess this will be sorted. Now it is sorted. And this is the exact same code in this cell. I have 2 for loops and I have swapping inside. And we are going to very quickly end with some libraries. Just like functions, Python has libraries. We can call an library and we can call the necessary APIs from those library to use the whole thing. For example, I want to draw a plot. In a very low level programming language, I have to like define everything, take a window, color it white, and then draw all the dots and connect them. That's like a whole lot of task. But in Python, I can just use the matplotlib library and I can just write plt.plot. It will plot the values for me. So it's just one line to draw a whole big graph. Python has like a lot of libraries, and the most popular Python libraries are for machine learning. We will see how can we implement those machine learning libraries, use those machine learning libraries to implement machine learning algorithms in our next lecture. But this is like the very basic introduction of what is a Python library. We have to import a library at the very beginning of my code. And when we import, all the functionalities are imported in my code. Now I can use that. I guess this concludes today's lecture. Just one more thing, that there was a bonus slide. I guess I am kind of at the end. So Python has a very interesting library that's called pandas. Pandas has a different data structure, data frame. This is not Python's basic data structure. We have seen list and tuples. Those are basic data structure. But data frame comes from pandas library. And we will see how we can use the pandas library and data frame for reading very large files and processing them in our next lecture. Thank you, everyone. And this is the attendance. Yeah.
Okay. Just a quick reminder, this is the attendance tracker again. If you didn't do this in the beginning of the session, make sure you do this to grab your credits. And I know some of you who are not from a tech background and have never coded before, some of that might look a little bit scary. So just follow along with the code that's going to be shared with you. And like I said, we're on Slack, so it's a community now there. So ask any questions you have. We'll have our own little Stack Overflow, I guess, in there. And I'm sure a lot of people will be happy to answer your questions if they have done that themselves before. And with that, I will see every one of you next week. Thank you.